Okay, so we are going to get started on the female reproductive system, and a lot of differences between the female reproductive system and the male reproductive system. The main things that we're going to be looking at here today are going to be the ovaries. That's what our focus of today's discussion is going to be all about, the ovaries and what they do and how they produce eggs. We'll get to the rest of female anatomy later, but obviously a whole lot of differences there. Now, if we start with the gamete producing structure of the female, we start with the ovaries. The ovaries are a pair of organs that are found in the upper pelvic region. They're held in place by a bunch of different ligaments. These ligaments will actually sometimes be sore when a female is pregnant. They kind of get overstretched as the belly extends. And the whole job of the ovary is to release secondary oocytes. We're going to use the term oocyte, we're going to use the term ovum and egg all kind of interchangeably. So really when we say ovum or when we say egg, it could refer to many different states in which the reproductive cell of the female might be in. Technically, an ovum is the last stage, the one that's actually released during ovulation, but we're not going to get super technical on that. So the ovary itself has a lot of histology to it. When you slice it open in cross-section, like you see in this diagram right here, you see many different layers. These layers are defined over here. The germinal epithelium is that outer layer right here. The ovarian cortex is made of dense connective tissue right below it. You can see this arrow pointing to it there. The medulla, we see that word again. We also saw that in the brain. In this case, the medulla is referencing the tissue that is deep in the ovary. It looks pretty much the same as the cortex when we just kind of look at it, but it's deeper inside, so it gets a different name. And then the follicles. The follicles are all over the ovary. And what's important to note here is that in this diagram, this doesn't mean that a follicle changes from one stage to the next and goes around and rotates around the ovary. It just is trying to show you all the different stages in one ovary. The cell doesn't really travel and traverse around the ovary, but this is the most convenient and useful way to show all the different stages that an oocyte will go through prior to and after ovulation. So again, oocyte is the term that we usually use to refer to the cells that will possibly develop into an egg. And then the last part, histology of the ovary, is called the hilus, and it's not labeled right here, but it's right there. And that's where the blood vessels, our arteries and veins, our lymph vessels, our nerves, all make their way into the ovary. So just like what happens in the male during spermatogenesis, we have oogenesis. It's not pronounced oogenesis, but I wouldn't mark you wrong if you said it like that. We produce ovum in the ovaries. Now, in baby bio, we learned that one cell becomes 4 in meiosis. But if you remember from baby bio, that one cell that divided into 2, which divided into 2 again, in baby bio we learned that only one of them is going to end up actually being a fully developed egg, and that is true. But what we did not learn in baby bio is that in actuality what happens is that the first part of meiosis occurs and produces what we call primary follicles or primary oocytes before we are even born. And then the process of meiosis kind of freezes until we reach puberty and start developing the hormones that are associated with ovulation and egg production. So those follicles develop into primary oocytes. So this step right here, like I said, occurs in our fetal development. So we actually have all the primary oocytes that we'll ever have, but when we're born. That doesn't mean that all of them are going to actually develop into fully functional eggs, but we have all the building blocks there. So what's kind of strange about this is that during fetal development, so that means in utero, so a female who is an infant inside her mother has the eggs for her mother's future grandchildren inside of her. Weird. So at this point, once the female hits puberty, then we have a cascade of different hormones that occur. We've already heard about GnRH when we talked about the male, gonadotropin-releasing hormone. FSH and LH come from the anterior pituitary gland, and they stimulate that primary oocyte to make that division into what we call a secondary oocyte. And at this stage, what's gonna happen is the cell is gonna divide its DNA equally. So we're gonna go from being diploid, which means 2N, to being haploid, which is just N. But we're going to do it unequally in terms of cytoplasm. So now that we're a secondary oocyte, and you'll notice that I have the term follicle also there as well. It's sometimes used interchangeably as well. That secondary oocyte, it's haploid now, and it is developing into what we call a very mature follicle. Another term for that is a Graafian follicle, and that's this stage right here, where essentially you can see it just kind of, that original follicle gets bigger and bigger and bigger and becomes a mature follicle like you see here. And what's happening at this stage is that the egg, the future egg, is really just right here. The future cell is just right there. And it's being surrounded by all of these supporting cells to nourish it. Because what happens during that one time in the month that a female is actually going to produce a fully functional mature egg is that in actuality there's maybe 8 or 9 cells that are starting to develop into a secondary oocyte, but at one point they just kind of abandon all of them except for one of them, or in strange cases where females do in fact release more than one egg, maybe 2 of them, and they only put all of their resources into one egg maturing. And when that egg matures, it's going to rupture out of the ovary, and we call that ovulation. So the secondary oocyte goes out into the uterine tube, also known as the fallopian tube, and that's the end of meiosis 1. So we still haven't made 4 cells here yet. So if we remember from baby bio, we should end with 4 cells. And the next stage of meiosis 2 actually doesn't even happen unless that egg is fertilized. When we become the secondary oocyte, we're N, and we were a primary, and we become a secondary oocyte. So this is primary, secondary, and so we release this guy, which is called the polar body, and it's essentially the reject. This cell got all the cytoplasm. They both have the same DNA, but this cell got all the machinery for a cell, and this one got nothing. It has the DNA, but it's got nothing. So it's kind of like a little reject. And the first polar body will actually divide again. So far we've made 1, 2, 3 cells. We still have one more to make. So meiosis 2 is only going to occur if the cell actually gets fertilized. So that, again, is very different than we learned it in baby bio. We just kind of learned the beginning game and the end game in baby bio. So meiosis 2 occurs if the cell is fertilized. So if the cell is fertilized, that cell that was in hangs on to all of its DNA and actually will kind of have a mitotic division. So it's kind of more mitotic division, and it'll release a second polar body. And there's our fourth cell. I can't write with my finger very well, guys. If that egg is fertilized successfully, it gets a new name called a zygote, and a possible future baby if this zygote implants into the uterus wall. Now, what's left behind in the ovary is actually what's called an ovulation wound, called the corpus luteum. And essentially, it's going to fill in with hormones, and it'll depend on whether or not a female is pregnant, will depend on whether or not the corpus luteum stays intact. If a female does have this egg fertilized, the corpus luteum is going to stay. It's going to hang out for a little while. It's going to secrete some hormones and keep the body ready to nourish a growing fetus. If not, it's going to scar up and become the corpus albicans. It's essentially what's left over because we don't need the corpus luteum anymore. So again, just kind of an overview of what we've already talked about. In fetal development, oogonia divide, and then most of them aren't going to actually be made into anything like a primary oocyte, even in fetal development. In fact, when females are born, they've got about 200,000 up to 2 million in their ovaries, kind of waiting in this suspended state of meiosis. But by the time she's actually mature, there's only about 40,000. Now, if you compare that to the numbers that we get with sperm, we're making 300,000 a day. So you can kind of see that it's a little more about quality rather than quantity with the ovary. That doesn't mean they can't still have mutations, but the female kind of version of gametogenesis is very different. So hormones are what causes meiosis 1 to jumpstart every month. And that final stage of meiosis doesn't even occur unless there's a sperm that penetrates the egg. And this is a review of oogenesis. We just kind of talked about all those stages. You can take a look at that again. And that is all. Have a good one.